Okay, guys, let me work through number 4 from the classwork. And if you want right away, you could print out the answer key for this that I've already posted on the weekly plan, or maybe it's on Classroom already, and follow along looking at the notes. Up to you, or print it out later, whatever you want to do, or write it as I talk about it, whichever you prefer. All right, so we're given data. We have to analyze the data in order to come up with the rate law. The rate law describes in an individual reaction what occurs, how fast the reaction will occur, depending on how much, what the concentration is of the substances, of the reactants that you have. So that's what we're thinking about here. So for A, the rate law needs to look something like this. We got to figure out what goes after that K, though. The rate is the R, the K is the constant, which changes based on every single reaction. Okay, so let's analyze some of this data. Let's keep in mind that the brackets mean concentration, and that concentration is molarity, moles per liter. So if a problem says moles per liter, after a number, don't let that throw you off. That's molarity, that's the concentration. You can just switch the moles per liter for an M if you want. All right, so I'm going to start by looking at 1 and 2, like we did in class. And so analyzing trials 1 and 2, I see that A and C remain the same, but B, the concentration is halved. And then I analyze the rate that occurs, the rate change, and there is none. So there's no rate change when we change B. So we say that B is 0 order. So to check that mathematically, what you could do is say, okay, well, the concentration was halved there, half the concentration of B. What happened to the rate? The rate was times 1. It didn't double, it didn't half, it stayed the same. So 1/2 raised to what power gives you 1? 1/2 raised to the 0. Any number, anything raised to the 0 is equal to 1. If you need me to explain where that comes from, that's algebra. I can do that another time. So we say that B is raised to the 0 power. Doesn't change the rate by changing the concentration. All right, let's look at 2 and 3 now. When we look at 2 and 3, 2 and 3, I see that B stays the same and C stays the same. So that will give me information about A, and A is halved. And so what happens to the rate? So if you want to do this mathematically, well, hopefully you can see 8 divided by 2 is 4. It's divided by 4. Or you could say, okay, we have half the concentration, we have 1/4 of the rate, however you want to look at it. So if we have half concentration, brackets concentration, we have 1/4 of the rate. What power is that raised to? The answer is 2. Whoops, I'm too high. So that is a second order reaction. Second order with respect to A. All right, let's look at, we need to figure out C. When we change C, so C doesn't change 0.15, 0.15, 0.15. We can go 15 to 30, that doubles. That's good because A doesn't change in 3 and 4. B does, but it doesn't matter because B is 0 order, so that won't affect the rate. So the only thing that could possibly affect the rate is C. So when we double the concentration of C, what happens to the rate? It multiplies by 8. So if you can't see that automatically because these numbers are so small, you could divide the two and it'll give you that ratio that you need. Put that in the calculator, those two numbers, and you get 8. Okay, so the rate has changed by 8, increased by 8, because that's -7 and that's -6, so it's a bigger number. Put the bigger number in first, put the smaller number in second. Otherwise, you're gonna get 1/8 in a decimal number, and you won't maybe recognize that as 1/8. So when we double the concentration of C, we get 8 times the rate. So we solve for X, and X is going to be 3. So this is third order. So C is third order. Okay, I'm going to erase this. All right, so our rate law. Rate equals K times A squared. B we leave out, and C third order. Calculate K for this reaction. So we're solving for K. We can use any line of work and plug in R, A, and C. Any line will give you the same answer. I'm just going to stick with trial 1. Trail 1, it says trail. This also says 1, it should be 4. And trial, not trail. So the rate is 8 times 10 to the -7. This is meters per second. If the units are like too much for you, you can probably leave the units out. We're solving for K. A's concentration is 0.10. It's kind of assumed that the unit's molarity when you put it in brackets in these problems, so you certainly don't have to put that. I just kind of want to put it for at least one problem to show you how to get the units for K. All right, now you put that into the calculator carefully, maybe twice, I don't know. I put it in, I'm going to write, I'm going to show all my work. Combined all this right here, and I got, maybe you want to practice making sure you're putting in the calculator correctly. And to the 5th, because 2 plus 3 is 5. When you're multiplying exponents, you add. All right, now I get K by itself. So I'm going to divide by the 3.375 times 10 to the -5th and to 5th. Do the same thing to this side. 3.375 times 10 to the -5th and to the 5th. Leaves me with K. Okay, so K, I'm going to put this in the calculator, is 0.0237. Don't be afraid of small numbers. We're going to have a lot of small numbers. All right, now the units. There's a trick for units. I'm going to show you, but I'll tell you what the trick is later. So our math is m over s divided by m to the 5th. And if we make that into a fraction, it's m over 1. When you divide a fraction, you multiply by the reciprocal. 1 m will cancel there, and 1 will cancel here. So our unit for K is going to be 1 over s m to the 4th. Crazy, huh? Don't let this stop you from completing that. If you get stuck on K, don't worry about the units. Don't spend an hour on units. Another way you might see it written would be like this. So like an inverse. So 1/2 would be 2 to the -1. So just utilizing that idea, that mathematical fact that we know. Because if you're going to write that unit, if you're going to write this unit behind this value of K, you've got a 1 in the numerator. So it makes it a little tricky. So normally we will see, you don't need a plus dot there. S to the -1, m to the -4. There's your value of K. I'm losing my voice. All right. Determine the rate for trial 5. So trial 5, we don't have the rate, but now we have everything else. I'm going to rewrite the equation and just plug in all those numbers. Rate is what we're solving for. Okay, we just calculated. Yeah, I'm going to leave the units out. A is 0.15 in trial 5. Square it. B we leave out because it's 0 order. 0.20 cubed. Okay, practice plugging that in the calculator and make sure you're doing that right. You already did it twice. It's rate, so rate is always going to be meters or molarity per second. And with those units of K, that's what you're going to wind up with. Okay, so the trick for the units for K is that you do 1 over the time. So in this case, it's in molarity per second. It might be minutes. And so the minute, it might be minutes instead of seconds. That's allowed. Just look at your units there. And then the M will be the order of the reaction minus 1, which is 5 in this case. So what's the total order of the reaction? 5, 2 plus 3. So 5 minus 1 is 4. Actually, I think in class, I might not have had it in the denominator. It might have been in the numerator. It's going to be in the denominator so that it all cancels out. Okay, so that's where we got those units. All right. D, determine the concentration of A when C, concentration of C is given and the reaction rate is given. Okay, this is some fun math. Same equation. You can write parentheses if you want. I just used the writing brackets with concentration. I'm gonna leave the units out because the numbers are enough. All right, the case, the same K as we calculated above times A. We're finding A, still squared, and concentration of C is given. And that's still cubed. All right, so I'll show all my work here. I'm going to put these two guys together. Multiply. So cube 1.175, and then multiply it by the value of K. And I will get 1.27 times 10 to the negative 4. 4. And A squared is still there. You can drop the bracket if you feel like it. This stays here. Now we solve for A. Well, we're solving for A squared first. Those cancel out. Divide. 6.5 times 10 to the negative 7 divided by that. It would be 0.00512. I don't know about significant figures. Just give me a handful of digits. And then that gives us A squared. So now we still have to take the square root. Because square root of a square leaves you just with A. 0.0715. A little fun way of, fun, not really fun, but a trick I use in the calculator. If I have that number in the calculator, I just raise it to the 0.5. I raise it to the 1/2 and you get a square root. Instead of having to find your square root key on the calculator and retyping 00512, I just keep it where it is and then hit raised to the 0.5, and that'll take the square root. And that is concentration. So the unit is M, molarity. All right, you want to check your work? If you're feeling crazy or insecure, go ahead and plug it all back in. Okay. Your newly found concentration of A and your given concentration of C. And you put all that in correctly, hopefully into the calculator, you will get something close to 6.5 times 10 to the negative 7. Might be a little off because of rounding, but it'll verify that you did it right. All right, I would say if you guys like really have a horrible time tonight, don't spend 2 hours on this, come and see me in homeroom and we can work through the problems in homeroom. I'll be in Miss White's room, probably 114. All right, see you.